So here let's see a numerical. So there is a matrix. They want they are asking to calculate x, and x lies on which curve. Means if you get what value of x something, so on x axis where is the x. So by the shortcut method of 3 by 3 matrix, you write the matrix here, first two column right here. Then by calculating x we got 3. Then if x is 3, just plot x as 3 on the graph. So here on the graph 0 1 2 3, so x is here. So there is no y value, there is only x value. So we draw a straight line. So x is parallel to the y axis. So the answer will be the above determinant represent which curve. Here the answer will be x is parallel to y axis. See in this numerical, this is the data they have given. So here you can separate these two elements as there is a property for this. So I wrote here ABC, ABC here, ABC, XYZ, XYZ. So here it will come ABC plus 2x plus 2 plus plus 2z, XYZ. So here two rows are same. So the determinant of this will be 0. Here I took 2 common from this row. I can take 2 as common. So here there will be only xyz. So there is xyz here, xyz here. So here also two rows are similar, identical. So here also the value will be 0. So 0 plus 0. So suppose you got like this matrix and they want a determinant for this. So if there is 1 1 1 in a column, you can transform these two elements as 0 by doing the row elementary operations, and then you only have this one. So it is easy to get the determinant of this. So if you do this operation, r2 is r2 minus r1 and r3 is r3 minus r, so r2 minus r1, that is 1 minus 1 0, r2 1 plus a minus 1, so 1 minus 1 gets cancelled, so a here, 1 minus 1 0, r3 is also r3 minus r1, so 1 minus 1 0, 1 minus 1 0, 1 plus b minus 1, so 1 minus 1 cancel, so there is only b remaining. So here we take 1 and we calculate the determinant by taking the minor, so a b minus 0 into 0, so a b minus 0, so you got determinant as a b. Similarly, if you get this pattern where you have 1 in a column or row, you can convert this into 0. So this method is called row echelon form, where you convert the elements below the first element as 0. So these three will become 0, and you don't will not change this, only change these three things. So by doing this you will get 0 here, and then expand it through by taking 1. So 1 into a into b into c, so you got abc. So these are the determinant properties. from the book named B.S. Grewal. This is the author of the book. So the first property according to this book is a determinant remains unaltered by changing its rows into columns or columns into rows. So it also means A is equal to A transpose. So we have seen this. If we write the row in column and calculate the determinant, the value will be same for both A and A transpose. Next is if two parallel lines of a determinant are interchanged, the determinant retains its numerical value but changes its sign. So if two columns are changed, then the determinant retains numerical value. So the value will be same, just the sign will be different. So in third property, the determinant vanishes if two parallel lines are identical. So if two rows have same elements, the determinant will be 0. In fourth, if each element of a line be multiplied by the same factor, the whole determinant is multiplied by that factor. So if we multiplied a scalar quantity to a row, then it also gets multiplied to the determinant. So k comes out, so it is multiplied by determinant. This is what they have telling. So in sixth, if to each element of a line be added equimultiples of corresponding elements of one or more parallel lines, the determinant remains unaltered. So if we do like this, R3 is equal to 2R2 plus 3R1. So these are the multiplies, meaning 2 into 3 is 6, 3 into 2 is also 6. So by doing this, here it will come minus. So by doing this elementary operation, the determinant will not change.